Abraham, they later brought the light back. Yes. Once they take it, they bring back, have you?
Hey, Ben. Good evening, sir.
Vicky, how are you? Okay. Right. Right about. Where are you? See you now. Why are you hiding from me? Where are you?
No.
Just search for special. Okay, that is where you are hiding from me. Found you. That is where you are hiding from me. Found you. Okay. Yep. I'm gonna quickly get to educateapplicants.com. Hello and welcome. So we're going to continue from where we stopped, educateafricans.com. Today is Thursday and we're going to be looking at mathematics. Mathematics. Okay. So please, this is the mathematics we are using now. This very first one. Take notes. That is what we are using now, okay? So I'm gonna scroll down. Okay, this one is starting up with longitude and latitude. That is what we're gonna be looking at today. Longitude and latitude. Longitude and latitude. Okay, the last class we checked out what's it called? Base numbers. Let's check out each longitude and latitude. Okay, so let's get the concept behind what we are trying to learn. Longitude and latitude. You can see here longitude and latitude. The equator at the middle. The longitudes are the horizontals. The latitudes are the verticals. Okay, let's read through. Let's read through. The lines of longitudes are imaginary lines drawn on Earth's surface. These lines are drawn running vertically from North Pole to South Pole on the surface of the Earth. So those lines that run from North Pole to the South Pole, they are the vertical lines. Vertical lines. The longitudes are the vertical lines, whereas the latitudes are the horizontal lines. Chika, how are you?
Fine. Good evening, sir.
Okay, so Chika, this is where we went from. Yeah, welcome, Chika. How are you doing?
Sir, can you
So Chika, yeah, I can hear you, Chika. Chika, this is the mask we are using now. This very first one here. We are no longer using the old one. So these ones are done in such a way that they are very effective. No much errors in the write-ups. So this is the mask we are using now. The very first one, you can see by Zimozo. That's the one we are using now. We are no longer using the old one. This is what we are using now. So once you come here, click on this mask, you'll be led into this. You're going to find out that the first topic here is longitude and latitude. We are just updating these ones now. That is what we are using. After updating, we'll rearrange it so that base number and other lesser difficult topics come first before the other one. So take note, that is what we are using. And we did that to make sure that we are delivering better for you. So we are looking at longitude and latitudes today. We want to learn how to do calculations involving longitude and latitude. You're going to find out that in the last time we may not have done this. So we're taking our time to look at mostly topics we are not able to do in the last time and move forward from that. So we're looking at longitude first. So whenever you're talking about longitude and latitude, your brain should go to this map of the globe or the world, this globe. So these vertical lines that are circular or geode, as the case may be, or spherical, as the shape of the earth may be, the vertical ones are known as the longitude, whereas the horizontal ones are known as the latitude. So we have longitudes and we have latitude. So you can see longitude, we are talking about these vertical lines, the red and the blue ones. Whereas for latitude, we are talking about these horizontal ones. So that's why in the definition of longitude, we say longitudes are lines, the lines of longitude are imaginary. They are imaginary. It does not mean that when you put a telescope or when you're looking at the earth that you'll be seeing these lines. These lines are not there. They are imaginary. We just put it so that to enable calculation. So they don't come on the earth. It's not as if you go somewhere, you're looking at the earth, you're seeing this longitude and latitude. But they are imaginary so that you can use the fact that they are there to do calculations. So that's why we say lines of longitudes are imaginary lines drawn on Earth's surface. These lines are drawn running vertically from North Pole to South Pole on the surface of the Earth. So they run from the North Pole. This is what we call the North Pole. And this is what we call the South Pole. So they run from this North Pole to the South Pole. So there are plenty of them. And they are known as longitudes. Whereas latitudes are the horizontal ones. So from what I've explained now, Chika, I want you to look at this diagram and mention two latitudes that you've seen and also 2 longitudes that you've seen in this very particular diagram we're looking at. Mention them. 2 longitudes. Start with longitudes first. Then after you mention 2 latitudes, because some of the lines there are labeled. So from the labeling, can you give me the 2 longitudes there?
The prime meridian is long.
So you can see the prime meridian, which is at 0 degrees, and the meridian. 2 of them are longitudes. Can you give me 2 latitudes?
The line at the equator and the parallel latitude.
The equator, and the parallel latitude. 2 of them are the latitude. Perfect. So having known this, that means we can go forward because you already know what I'm trying to say. So the lines of longitude are also called meridians. Another name for longitude, the lines of longitude are also meridians, and they vary from 180 degrees east. So they can go 180 degree east, 180 degree west, 180 degree east, 180. So you can have plenty of them, but the highest is 180 to this side and 180 to this side. 180 east, 180 west. However, for the purpose of locating positions on the Earth surface, a longitude is half of a meridian. This side is half of a meridian. A meridian is when you take it 360 degrees. Without just one section. Now, there is a particularly important longitude or meridian. We call it the prime meridian. It passes through the Greenwich in London. This prime meridian is 0 degrees. It is used as the reference meridian from where the positions of other longitudes are measured in degrees towards the east or west. So the reference meridian is the prime meridian. So you can see it's located here, prime meridian. Okay, let's keep going forward. Now, all longitudes to the left of the prime meridian are measured from 0 degrees to 180 degree west. So all to the left, 0 degrees to 180 west. And those to the right from the prime meridian measured from 0 to what? 180 east, 0 to 180 west. Let's keep moving forward. Now let's look at, so you can see them here. So we have 0 to 180 east, 0 to 180 west. So take note, this will help you when you're doing your calculation so that you don't make mistake. This is north, this is south. So to the east, 0 to 180, to the west, 0 to 180. So take note. Now let's look at latitudes. We've already known what latitudes are, but let's also look at the documentation. A latitude is a cycle that is drawn on the Earth's surface, having its center on the axis of the Earth. The axis of the Earth is the imaginary straight line, which runs from the North Pole through the center of the Earth to the south. All the circles are parallel to each other, and they are usually referred to as parallels of latitude. So why do you call them parallels of latitude? Because they are parallel to each other. Now take note. The meridian, all of them are of equal size. Chick, are you aware that all the meridians are of equal size? Because they are somehow passing through the middle, not pole to the south pole. But for the parallels of latitude, as they are going up, the sizes are decreasing. Chick, can you notice that? Can you see the equator? The diameter of this equator is bigger than what you have for this other latitude. What we have for this, as it's going up, it is decreasing. As it's going down from this equator, it's decreasing. But when you talk about the meridians, they are always of the same size. Chick, are you able to recognize this difference between the longitude and latitude?
Yes, I am.
Okay, so let's keep moving forward, having gotten that. The latitude of a place is measured in degrees north or south. The other one is measured to east and west. This one is measured north or south of the equator. Whereas the other one for longitude is east or west of the prime meridian. The prime meridian is the reference point. For the latitude, the equator is the reference point because the equator is at the middle. Now, latitudes vary from 90 degrees to 90 degrees north to 90 degrees south. You see, the other one, we are talking about 180 to 180. Whereas for longitude, we are talking about 180 to 180. That's the limit. For the latitude, the limits are 90 degrees north, 90 degrees south. Now, the line of latitude, which has the same center as that of the Earth, is called the equator. Equator has the latitude of 0 degrees. Just the same way the prime meridian, which is the meridian passing through the Greenwich in London, has the longitude of 0 degrees. That's the same way the latitude of the equator, the reference point for the latitude, is also the 0 degrees. So are we clear with all these simple facts? Okay, all latitudes to the north of the equator are numbered from 0 to 90 north, while those the south of the equator are numbered 0 to also 90 south. So let's keep moving forward. So that is what we see here, 0 to 90 north, 0 to 90 south. Now let's look at great circles and small circles. A circle with the largest radius, which is drawn around a sphere with a common center x and equal radius r, as that of the sphere, is referred to as a great circle. So from here, it is clear that all meridians are great circle. That's why we say all meridians, all the longitudes, they are of the same size. So all of them are great circle because they can divide the Earth into 2 equal parts. So all of them are great circle. Now, only the equator is the latitude that is a great circle. So we say also the equator, all other parallels of latitudes are small circle. They are not great. So great circle is any circle that has the radius of the east radius is the same as the sphere in which it can be found. In that case, it can divide the sphere into 2 equal parts. So all the meridians are great circle. Only the equator is the great circle for the latitude. Michael, am I making sense? Hello, Michael, if you want to speak, you're on mute, so you unmute yourself.
Yes, sir. Sorry, sir.
Okay, thank you. So let's move forward. Let's look at small circles. Now that we've known what great circles are, let's look at what small circles are. Now, all circles on a sphere of radius r, whose centers and radii do not pass through the center of the sphere, are called small circle. So apart from the equator, all the other parallels of latitudes are all small circle. Why? Because they cannot divide the Earth as a sphere into 2 equal parts. So you see, most of the latitudes are small circles. It's only the equator that is a great circle because the equator can divide the Earth into 2 equal parts. Now let's get to the main thing that we need to learn under longitude and latitude. You're simply going to be studying location of places on the surface Earth. That is the essence of longitude and latitude. Calculation of location of places on the Earth's surface. That is what we are going to be doing. Once you are done doing it, then you are okay with longitude and latitude. So let's start up. Now, to determine the position of a place on the Earth's surface, it is easy task. The position of the place is located by finding the point of intersection of the longitude and latitude of such a place. To do this, the student will just use a free hand to draw the sphere and locate the prime meridian and the equator from freehand drawing. Then the other longitude and latitude are drawn as supplied in the question. So for example, you have a point P and you're told that to the north. So whenever we're talking about to the north, you know we are referring to the latitude. It has the value of x degrees. Whereas in terms of the meridian, it has y degrees east. So take note, the north and south refers to the latitude, whereas the east and west you're talking about for meridian. This means that the position of P is at latitude x degree north. I told you this first reading is always for the latitude, x degrees north. and longitude, y degree east. So this second one is always for the longitude. In fact, whenever you see east, then you're talking about the longitude. When you hear north and south, you're talking about the latitude. So where this x degree north and y degree east intersect is the location or the position of the point P that is required. So take note, that is how you locate a place on Earth surface using longitudes and latitudes. Now we're going to go further now to trying to use it in actual examples. So this is example 1. So this point P is at 50 degrees north and 80 degrees east. So if you want to locate this point, the first thing you do is that you use your hand, draw your sphere. Once you draw your sphere, the next thing will be to draw your equator, those reference points, equator, west to east, this is it. Then prime meridian, we all know, this is it here. Then from there now, read out these points. So the point is 50 degrees north. So this is your, what's it called? This is your 0 point of the equator. So you have to go in such a way that you have 50 degrees. So, but first of all, it's better you locate your, first of all, just locate your meridian. So if this is 0, this place is 0. So we need to go to 80 east. So this is the point of 80 east. And also, this is the point of 50 north. 80 east, 50 north. So this is 80 east. This meridian here is the 80 east. This very line here is the 80 east. Then 50 north is this very one. You remember this is 0. So as increasing, it gets up to this place, which is 90. So at this point is 50. Whereas this one is 0 here. As it's going, it gets up to the half, which is the other side, which is 180. But here now is 80. So the point of intersection between this very vertical, which is 80, and this horizontal, which is 50, is this very point. Okay, let's keep moving forward. I think we'll understand it more. Okay, so let's look at this angle between two places on Earth. So this is another very important calculation that you'll be doing using this very longitude and latitude. If you're given 2 points and you're supposed to find the angle between them, you're supposed to know how to locate the angle. So let's do that. Now, before any calculation can be done concerning the places on the Earth's surface, the angle between the 2 places whose distance is to be found must be known. Before you can do any calculation, you have to know the angle between those 2 places. And that is why it's good we know how to do this calculation. Now, in determining the angle between 2 places on the surface of the Earth, the following methods are used. Now, add together the degrees of the longitude. So when longitudes are involved, add together their degrees. If one is east and the other is west, if one is east and the other is west, that's when you add. If they are the same, you have to subtract. You only add if they are, like now, if you're looking at this point, X and Y, the longitude here is east, here is west, so you must add. And even it's east, you have to subtract. So take note, you must note this. So the angle between the 2 points X and Y is the sum of 60 and 70, which is equal to 130. That means the angle is 130. So P being the center of the latitude. So take note of this. So I'm going to go down. Now subtract the degrees in longitude. If the 2 locations are the same place, so if both east or west, then you have to subtract. So take a look at these 2 points, P and Q. You can see that 40 east, 90 east. So 2 of them, the longitudes are the same, east. So you have to do 90 minus 40 in order to get the angle. And 90 minus 40 is 50. And that is also what is shown on this diagram. So take note. Whenever you're having 2 points that you want to compare their distance, they're always going to give you, the latitudes are always going to be the same thing. You can see this is 40 degrees, 40 degrees. So what you're considering is just the other one. Can you see 40 degrees, 40 degrees here? So that's why you're not considering latitude. You're just going straight to the longitude. If you come here again, 15, 15. And this point is the point of 15 to the south. You can see up here we have 40, 40 to the north. So you must locate this point. So whenever you're giving this, just locate your longitude first. Then from that, your longitude, you now try to locate where your latitude is, taking the prime meridian as your reference point. So take note, angle between two places on the earth, if they are on the same side of the longitude, you subtract. But if they're on different parts of the different sides of the longitude, you add. Take note of that. Those are very important before we start most of the things we'll be doing, okay? So let's look at these. So subtract in this case, and we subtracted and we got 50. Then let's look at these other 2 points, A and B. So we have 60, 60. Then we have west, west. So who will tell me what will be the angle between these 2 points, A and B? Chika, can you help me? Oluwase, can you help me? Once you can help me, you can start talking. What's the angle between these 2 points, A and B? Who can tell me from what we've said so far? Let's start with Michael. Michael, can you tell me?
No, sir.
So Chika, can you help us? What's the angle between point A and point B?
Sir, I think it's 50 degrees.
53.
Yes.
You say 53. So how did you come about 53? Oluwase, can you help us? Oluwase, can you help us?
I thought the angle would be 75.
Okay, it says 75, perfect. Because whenever you're given this, you don't consider the latitude. The latitudes are the same. So you just consider the longitude. When it's west-west, you have to subtract. Or when it's east-east, you have to subtract. But if it is west and this one is east, then you have to add. So you can see that two of them are the same side, west-west. So you have to subtract. So in subtracting, you have 105 minus 70, which is 75. Perfect. So you can see the answer here is 75, so it's perfect. So what of this one? Who can tell me what will be the answer to this one?
93 degrees.
Michael, can you help me with this one?
It's 93, sir.
Okay. So add together the degrees now if one of them is not, and okay. So you have these two are the same. So we are looking at these two now. 63 plus. This is south and this is north. 93. Okay, it's making so much sense. Who can tell me what this one will be? What would this one be?
31.
31. This is not north, so they are supposed to subtract each other. 31. Perfect, perfect, perfect. Okay, so let's solve this problem. Find the difference in longitude between this and this. Difference in longitude. You can also already see that their latitudes are the same. So you can see that this is east and this is west. So when it's east and west, what do we do?
We add, sir.
Thank you. So it's 63. Okay, this is perfect. And we've come to the end of this, but very importantly, I want to also play this video. I think there is another solution, another way that I use in solving this one. Let's play this video and see other forms of calculations that we have. So please just watch the video. I will explain in the end. I know you might not be getting the volume, but you're going to see me solve something, so pay attention. Now, when you have an object and you want to know the distance from one point of the object to the other, or you want to know the area of the object, or you want to know the value that the object has, of that calculation. So let's say you have an object, the rectangle, and you want to know the distance between one or want to know the area of the pie side of the pie side or object is a solid object, and you want to know the both of this object and study either the area of this object, the value of the perimeter, and do all this study on that. But now, when you're looking at the end surface, you're not talking about any other object, you're not talking about a sphere, you're not talking about a rectangle, you're not talking about a cone. Now you're considering the end surface. Spherical, spherical. So when you're talking about calculation of the end surface, notice that notice the distance points on the end surface, longitude and latitude, above you get the relationship. And that is why studying longitude and latitude is also just like normal equation. Most mathematics of that because it's also studying about points of the earth, getting the distance and understanding how to calculate on the surface of the earth. And that's what we're going to be doing in this course. Consideration for longitude and latitude. Now, looking at the shape of the earth is a very common. It is very important that we identify some important points on the earth. So now when you look at the earth, that very cycle at the middle of the earth, horizontal cycle, whereas the vertical cycle is known as Greenwich Meridian. So these very two points are very, very important, and they are known as great cycles because if we cross the earth through these very cycles, you're going to find two or five. So any point, any circle round the earth surface, any circle round the earth surface, look when you cut the earth down, get two or five, or the great circle, or the great circle. And the two better important great circles are the Equator and the Greenwich Meridian. And they are going to be used as reference points. I hope you're paying attention. I'm paying attention. Me, I'm paying attention to what I'm saying. So they're talking about the two major reference points, the Equator and the Greenwich Meridians. Those are the 2 points. So this is the Equator and this is the Greenwich Meridian. And they are great circles vis-a-vis the other latitude, which are small cycles. A great circle is that circle that when you cut through them, you can have two equal parts of the sphere. Example is the equator, and example is all the meridians, including the Greenwich Meridian. The longitudes. The circles running from North Pole to the South Pole are known as the longitudes. They are the longitudes. And the most important one is the Greenwich Meridian. All the vertical circles are called the longitudes. And the most important of them all is the Greenwich Meridian, which is the reference. Then the horizontal circles, they are known as the latitudes. And the most important of them all is the equator, which is the reference point. So now you know them, you know the latitude, you know the longitude, and you know the reference point. Very important. That's point 2 in this class. Then point 3 is to determine and sketch the position of a point. That's the next thing we do. Number 3, the third objective, determine and sketch the point. Position of a point. A point on the Earth's surface. Distance from Nigeria to Ghana. You need to pick out these distances. So say point in Nigeria there. So you can actually get the position of a point by simply noting the longitude and the latitude. Just that. That's how you get the position of a body on the surface of Earth. Just know the longitude and latitude. Now, how do you calculate the distance between 2 points on a great circle? Very important. Calculating the distance between 2 points on a great circle. So you must make that sketch. A great circle, meridian, point P and point A. So you stretch from the middle to them. That's the distance you want to calculate between A and B on the equator. That means 2 of them are going to have the same value for equator, but different values for the longitude, because the longitude at point A is different from that of point B. Okay, and you can also calculate another form of distance from C and D, okay? Now we can also calculate of point on the S surface. Okay. So, Chika, did you make sense of the whole thing?
Yes, I understood.
Okay, so I'm gonna Michael, are you, which of our groups are you in?
I'm coming, sir.
Mm-hmm.
It's the WAEC, NECO, and JAMB class.
WAEC NECO JAM class. Is that the way the group name is written?
Yes, sir.
Okay, so I'm going to send an assignment to those groups on this. I'll quickly snap an assignment with my phone, then I'll send it. That's the assignment you people will do. Okay?
Okay, sir.
Yeah, thank you. Oluwaseyi, thank you. See you when I see you.